26. What is conduction heat transfer? Conduction heat transfer is the transfer of heat through a solid or stationary fluid by means of molecular collisions. In conduction heat transfer, energy is transferred from molecules with high energy to molecules with low energy. 27. What is the thermal conductivity? The thermal conductivity, K, of a material is a measure of its ability to conduct heat. It is defined as the amount of heat that flows through a material in unit time per unit area per unit temperature gradient. 28. What is Fourier's law of heat conduction? Fourier's law of heat conduction states that the rate of heat transfer through a material is proportional to the temperature gradient across the material. The equation for Fourier's law is Q is equal to K dt dx, where Q is the rate of heat transfer, K is the thermal conductivity of the material, A is the cross-sectional area, and dt dx is the temperature gradient. 29. What is the heat equation? The heat equation is a partial differential equation that describes the time-dependent behavior of a system subject to heat transfer. The equation is Tt is equal to alpha to Tx2, where T is the temperature, T is time, alpha is the thermal diffusivity, and x is the spatial coordinate. 30. What is convection heat transfer? Convection heat transfer is the transfer of heat through a moving fluid. Convection can be natural, caused by buoyancy forces, or forced, caused by an external source such as a fan or pump. 31. What is forced convection? Forced convection is the transfer of heat through a moving fluid that is forced to flow by an external source such as a fan or pump. 32. What is natural convection? Natural convection is the transfer of heat through a moving fluid that is caused by buoyancy forces, which arise due to density differences caused by temperature variations. 33. What is the Nusselt number? The Nusselt number, Nu, is a dimensionless number that describes the ratio of convective to conductive heat transfer. It is defined as Nu is equal to HLK, where H is the convective heat transfer coefficient, L is the characteristic length scale, and K is the thermal conductivity. 34. What is the Reynolds number? The Reynolds number, Re, is a dimensionless number that describes the ratio of inertial forces to viscous forces in a fluid. It is defined as Re is equal to rho VL mu, where is the density of the fluid with the velocity of the fluid list the characteristic length scale and is. 37. What is the Stanton number? The Stanton number, Street, is a dimensionless number that describes the ratio of convective heat transfer to the rate of thermal energy storage in a fluid. The Stanton number, Street, is defined as Street is equal to hCp rho u, where h is the convective heat transfer coefficient, Cp is the specific heat of the fluid, rho is the density of the fluid, and u is the velocity of the fluid. 38. What is the Biot number? The Biot number, Bi, is a dimensionless number that describes the ratio of heat transfer resistance due to conduction within a solid to the resistance due to convection at the surface. It is defined as Bi is equal to HLK, where H is the convective heat transfer coefficient, L is the characteristic length scale, and K is the thermal conductivity of the solid. 40. What is the effectiveness NTU method? The effectiveness NTU method is a technique used to analyze the performance of heat exchangers. It is based on the concept of heat exchanger effectiveness, which is defined as the ratio of the actual heat transfer rate to the maximum possible heat transfer rate. The NTU, number of transfer units, is a dimensionless parameter that represents the ratio of the heat transfer surface area to the product of the minimum fluid capacity rates. What is the log mean temperature difference? The log mean temperature difference, LMTD, is a parameter used in the analysis of heat exchangers. It is defined as the logarithmic average of the temperature difference between the two fluids at each end of the heat exchanger. LMTD is equal to delta T1 delta T2 ln delta T1 delta T2, where delta T1 and delta T2 are the temperature differences between the two fluids at the inlet and outlet of the heat exchanger. What is a heat sink? A heat sink is a component or device that is used to absorb and dissipate heat from another component or device, typically an electronic or electrical component. Heat sinks are typically made of materials with high thermal conductivity, such as aluminum or copper, and are designed to maximize surface area for efficient heat transfer. What is a heat pipe? A heat pipe is a device that uses a sealed, evacuated tube filled with a working fluid to transfer heat from one location to another. Heat pipes are highly efficient at transferring heat due to their low thermal resistance and ability to transport heat over long distances. What is thermal resistance? Thermal resistance is a measure of the resistance to heat flow of a material or component. It is defined as the temperature difference across a material or component divided by the rate of heat flow. R is equal to delta TQ. Where R is the thermal resistance, delta T is the temperature difference, and Q is the heat flow rate. What is thermal capacitance? Thermal capacitance is a measure of the ability of a material or component to store thermal energy. It is defined as the ratio of the amount of thermal energy stored to the corresponding temperature change. C is equal to Q delta T. Where C is the thermal capacitance, Q is the amount of thermal energy stored, and delta T is the corresponding temperature change. 46. What is a thermal boundary layer? A thermal boundary layer is a region of fluid near a solid surface in which the temperature gradient is significant. The thickness of the thermal boundary layer depends on the fluid velocity, the fluid properties, and the temperature difference between the solid surface and the fluid. 47. What is a laminar flow? Laminar flow is a type of fluid flow in which the fluid moves in parallel layers or streams with little or no mixing between them. The flow is characterized by smooth, predictable, and ordered motion of the fluid particles. 48. What is a turbulent flow? Turbulent flow is a type of fluid flow in which the fluid particles move in a random and chaotic manner with frequent mixing between them. The flow is characterized by unsteady motion, eddies, and vortices. 49. What is natural convection? Natural convection is a type of heat transfer that occurs due to the density differences caused by temperature variations in a fluid. When a fluid is heated, it becomes less dense and rises, while cooler, denser fluid sinks to take its place. This creates a natural flow of fluid that can transfer heat. 50. What is forced convection? Forced convection is a type of heat transfer that occurs due to the forced movement of a fluid, typically by an external device such as a pump or fan. The flow of the fluid is usually turbulent and can be used to enhance heat transfer.